I2C, or I squared C as people now say it, is short for Inter-IC, which is a type of bus that was designed by Philips Semiconductor in the early 1980s. It's used to connect integrated circuits. I2C is a multi-master bus. So what that means is that multiple chips can be connected to the same bus, and at any time each of those can act as master, which means they can initiate the data transfer. How I2C works is that there's two wires, and with those two wires, one is called serial clock, or the SCL, and the other one's called the serial data, otherwise known as the SDA. So the SCL line is like the clock signal, which synchronizes the data transfer between the devices on the I2C bus and what's generated by the master device. Then the other line, or the SDA, carries the data. The data signal is transferred in sequences of 8 bits. So when the special start condition happens, the first 8-bit sequence happens. It indicates the address of the slave of which the data is being sent. And then after each 8-bit sequence, an acknowledged bit is sent. After the first acknowledged bit, in most cases, comes another address sequence, but this time for the internal registers of the slave device. After the addressing sequence follows the data sequence, and that happens for as many sequences that is needed to completely send the data, or a special stop condition is met. The gap layer of the Bluetooth Low Energy Protocol stack is responsible for the connection functionality. So there's different states of the device. There's the standby state, which is when the device is in the initial idle state upon reset. The advertiser state, which is when the device is advertising with specific data, letting any initiating device know that it's a connectable device. There's a scanner state, which is when receiving the advertisement, the scanning device sends a scan request to the advertiser, and then the advertiser responds with a scan response. And this process is called device discovery. There's the initiator state, which is the initiator must specify a peer device address to connect to. If an advertisement is received matching that address of the peer device. And then there's a slave and master state, which is when the connection is formed, the device functions as a slave if the advertiser, and a master if it's the initiator. GATT, which stands for the generic attribute profile, defines the way that two Bluetooth low energy devices communicate between each other. It uses concepts called services and characteristics. It also uses a data protocol known as the attribute protocol, or ATT. And what this is it's used to store and manage services, characteristics, and any related data in a lookup table. GATT comes into use once a connection is established between two devices. This means that the devices will have already gone through the advertising process managed by GATT. During this process, only one client can be connected to one server at one time. This means for the whole time that the client and server connected, it will have stopped advertising until the connection is broken or disconnected. Okay, so this is my video for the first assignment of IoT. This here is where I include the Excel service and the Mag service, which are other parts of the project. The line here in the device name, that's the device name that will be seen when you open up the Bluetooth scanner. I'm just going to change it here to project IoT. These are the pointers. they point towards the different services. Those are the I2C addresses for both the magnometer and the accelerometer. This is where the functions for both the update acceleration and update magnometer are called. This is where the pointers are declared, like a new variable. This is the code for the function void update acceleration, which updates the acceleration. And that's the code for the update magnometer. It's quite similar. Down there you see mag service pointer. That's to update the different axes. Ticker attach period callback is to this is where the accelerometer and magnometer both are updated every second. And below that then is the wake for both the accelerometer and the manometer from sleep mode. What that does is it sends 1 to the register number, which then wakes them up. Finally, here's the BLE scanner on my iPhone, showing the different services and showing the read values. You'll see the hex value change when I add some movements to the microbit. In the video attached, you will see me read the data multiple times to show different changes within it. And that concludes my video on I2C.